Hello, everybody. Welcome. We're going to kick things off here. Thanks, everybody, for joining. I'll let everybody file back into the amphitheater area. Welcome, welcome. For the folks here already, I'm curious, how many people joined for the meetup that we did here in December with Arize? Anybody? Okay, I see a few people. Awesome. So for anyone who doesn't know, we're doing a whole series of meetups over the next few months here, so there'll be more opportunities to join for these sorts of events. And hopefully the people who came to the last one enjoyed it and have come back again, so we'll have some good ones for you guys going forward. So in terms of the structure for the day, for the evening here, we have 3 talks that we're going to go through, and then we're going to have some time for kind of mingling and networking and everything like that. We're generally gearing things around these sort of advanced techniques within agent development. So either that's tracing, evaluation, deployment, speeding up inference, all kinds of different more advanced stuff. And we're trying to make it a little bit more hands-on for you guys today. So I'm doing a lot of live demoing in the talk in a second, so please pray for me on that all goes well. Yeah, and before we kick off, a couple kind of housekeeping announcements for everybody. Also, can we have the music turned off, please? I like the backing track, but I feel like it is distracting. So a couple of housekeeping things. We're trying a few new things today. One is that we're doing a giveaway challenge. So if you want to win a Theragun, we're going to be doing a social challenge here where all you have to do is post something about the event before 7:30 and tag either Arize AI on LinkedIn or Arize Phoenix on Twitter. If you're on Blue Sky and you want to do that, we're also Arize Phoenix on Blue Sky. And we'll pick the best post, kind of the most informative or special one, and that will be our winner. We'll announce it at 8. And so you can share like an insight photo, something you learned, takeaway, whatever it might be. Cool. And our Theragun is under the desk over there, so you will get to go home with the Theragun if you win. And then the other piece is that for anyone who doesn't know, we have a community Slack, and we're going to be using that tonight for a few things. So we're going to be posting the recording at the end of the night into that channel. We're going to be using this for some questions as well, too. So we have 3 speakers. We'll probably have a minute or 2 for 1 or 2 questions at the end of each. But then if you have other questions that you want to dump in the channel there, our speakers are all in the channel, and they can answer some questions for you afterwards, or other people in the community can jump in. And so we'll have that going as we go through. And one last thing that's not on the slide, we are also going to be giving away some Arize hoodies to folks afterwards. If you come and, is Nick visible over here? We'll have him in a sec. Okay, so if you go to Nick afterwards and you're willing to do like a quick 30-second interview of just something that you learned or something you got excited about, then we'll give you a hoodie. So more swag to go along with the socks. All right, and I think that's it for all of my announcements. So I am your first speaker. You guys are going to hear from a little bit more from me, and then we're going to pass things over to Lori and then to Ben from Groq as well, too. So we've got 3 speakers for you guys over the next hour. For me, we're going to be going through evaluating agents and assistants. Some folks who were here in the last session might recognize that title. I promise this is not the same thing that I went through last time. We're going to be doing much more of a live demoing version. So we're going to go through how you can use some of these techniques that we talked about in previous sessions. We'll recap what some of those are for folks who haven't been exposed to evaluating agents before. And we'll show you how you can not just build agents, but improve them, evaluate them, deploy them, all kinds of different things as we go. This is my most marketing slide. I promise most of this will be demoing and showing you guys code and things like that as we go through. But just to give you kind of a picture of Arize, what kind of our main thrust is here is that for anyone who's built with LLM applications before or with built agents, built assistants, whatever it might be, you've probably run into the fact that it's not a linear process. You're not like building, testing, and deploying, and then you're done. It's more like a cycle. You are consistently testing, evaluating, iterating, monitoring, and you're kind of all of that feeds into itself. And so we've really found that a lot of the sort of problems that you can run into can be fixed here by having a unified platform that allows you to do all of these things together so you can move between these different phases really easily. So you can move from tracing to evaluating to testing to monitoring all the way back, and it all kind of feeds into itself. And it blurs the lines a little bit from development to production, but you can kind of use one platform to be that ride along that can help you understand how things are performing, help you improve your systems, and help you continue to grow those systems over time. So We're going to focus in on how you can do some of this stuff with our tool Arize Phoenix today. And so we'll show some of that in a live demo in a second, but it gives you kind of a quick picture of Arize for anyone who's not familiar. All right, so for today, I mentioned we're going to go through how you can trace, evaluate, test, and improve an agent. So we have an example agent that I've built that we're going to go, and I'm going to show you how you can use some of these tools to do that. Everything I'm going to show you is open source, free to use. You can use it right now. You can self-host it, so we don't even get your email. You can do whatever you want with it. It's really meant to be as accessible as possible. So we have an agent that we've built that we're going to use. I won't spend too much time going into all of the details of everything, how it works. We'll share the notebook in the Slack afterwards as well, too, for folks who want to kind of go in and see the agent as it's been built. But the creation that we're going to be evaluating today is a database copilot agent. And we've used kind of a similar structure to what we use in most kind of basic agent examples at this point, which is essentially a router that's powered by some sort of LLM function calling that can then send to a bunch of different tools that agent has. Those tools will execute, return back to the router, and then that may go call more tools, that may go back to the user, can create this sort of loop as it goes through there. And again, this is kind of a typical structure that we see for agents. Obviously, it's not how every agent is structured, but it's kind of like a baseline structure that we'll use in a lot of cases. So for this example, we have a database copilot agent. It is designed to connect to a database and then allow you to ask questions of that data. So we've given it a few tools, a tool that looks up sales data. So in this case, our database is a sales database. It has a bunch of transaction rows and things like that. And so we can look up data from it by generating SQL code. We can do some data analysis where we're kind of putting in a large amount of data and then drawing some conclusions from it. And then we can do some more data visualization where we generate code to actually create a visualization that we can show to people. And then finally, we've kind of separated off a tool that actually executes the code that gets generated, more for like kind of safety purposes here, where we can execute the code in a controlled environment as opposed to having our agent just be able to run whatever kind of code it wants to. So this is our agent that we've set up that we're going to use for the demo. And then our whole goal is, again, to improve this agent somehow, evaluate it, understand how it's performing, and make it better. And so we have a few tools to do that. We are going to use Arize Phoenix, which is our open source platform. You guys will see a lot of that in a second. And it's all powered by OpenTelemetry tracing, so we'll talk a little bit more about that. And then we have a couple types of evaluations we can run, either code-based or LLM as a judge. And then we have, finally, this evaluation-driven development framework that combines a lot of these things into one replicable framework. Everybody with me so far? Cool. Is that a please move faster yes? I think maybe. All right. Cool. So I won't go into too much detail here, but again, Phoenix is our platform that we're going to use to do a lot of this evaluation, tracing, prompt playgrounding, a couple other things there. We'll share the slides after if anyone wants to go through these in more detail. Want to make sure we can get to the demo portion. And then in terms of evaluations, there's two kinds of evaluations we can do. One is this more code-based structure where we can basically just do typical kinds of tests on the outputs of our application or different steps of our application. So this example here is just checking if generated code that we have is runnable, just going to return a true or false. That's kind of a spot check that we can use for some of the evaluations we might want to run. You might have other ones that are checking against like regexes on the outputs. You might check if the output's parsable or JSON parsable contains keywords, a bunch of other things that you could try from there. So we have our code-based evals, and then we have LLM as a judge evals. Quick show of hands, who's familiar with LLM as a judge? Cool. Okay, that looks like most people. 2 seconds for anyone who's not. The idea behind LLM as a judge is you take the outputs of your application as well as some other information after it's run, take that, send it over to another LLM, and have that LLM judge how well you performed on a certain metric there. So you're using a separate LLM to judge your LLM application. So we have our two kinds of evals, and then evaluation-driven development is a framework that is basically built around this core idea of generating a data set of test cases, then sending those test cases through different iterations of your application, and then sending the results of that through some evaluators. And you can essentially try a bunch of different iterations of your application with the same test cases, with the same evaluators. You can compare and contrast, and you kind of let the evaluations guide where you're going to build the application and where you're going to improve the application. So we're going to use that structure as well. All right. First off, everybody say a quick prayer that nothing breaks in the live demo. Okay. Appreciate you going with that. Okay, is this mic on down here as well? Cool. All right, we're going to try this mic so I can use the computer as well. And so in what we have here, I won't go through all of our code because there's a lot of it. But again, we'll share the notebook for anybody who wants to follow along afterwards. And so I won't show everything in here. I got to stay up here. I won't show everything in here, but I will go through a few different pieces.
Wait, hold up.
Too quiet?
There we go.
You can read my mic stand?
Yeah, I'll read your mic stand.
It's okay, I can hold it. It's fine. I won't make you do that. But yeah, so we have our system here. This is an agent that we've created, and then we've connected to Phoenix. There's just a couple pieces we're doing to actually connect it through. So this essentially connects our application to a Phoenix application that's running in the cloud. You can also run it locally if you prefer to do that instead. And I'm going to skip over some of the code in here. If you guys want to see it, again, we'll share the notebook. There's a bunch of code defining all of our tools, preparing our data set. That's the database we connect to. And then for the agent logic, we're doing a lot of stuff to basically, again, we're keeping it very simple. We essentially have a while loop that's moving between the router and the tool call handling step. Again, we'll share this afterwards if anyone wants to take a look. And so once we have created our agent, again, we're just connecting here to Phoenix, and then we're using an instrumenter that we have here that will basically take any calls we make to OpenAI, and we'll make sure those are sent over into Phoenix and traced. I've also done some manual kinds of tracing to kind of mark all the calls that should be sent over into Phoenix. And so now if I go into our Phoenix repository, this is connected to the application that we just had. We did some demo runs through of some questions from users. So questions like, what was the average transaction value across all our sales, plotting the daily sales volume over time, plot a line graph that shows these different things. And then we can go and click into one of these and we'll get a more detailed kind of trace of what's going on. So this is our kind of basic tracing step to just capture what's happening inside our application. We can see our LLM calls, our tool calls. If we had other logic chains we wanted to do, we could see those as well. So this just gives us a detailed idea of what's happening. And the first thing that you should always kind of start with when evaluating agents is just gut checking. Just do some testing of it yourself. You're always going to start by just looking at, hey, the initial inputs and outputs, trying to see what's going on from there. Tracing is a really helpful tool for that early gut checking stage. And then we're going to use these traces to actually do some more detailed analysis. So from here, you could go into a couple different paths. One that I kind of like to do from this point is actually add in some LLM evaluations again, a little bit of a gut check, because LLM as a judge, for anyone who doesn't know, is not 100% accurate. It's not a guaranteed kind of label, so you have to treat it with some kind of caution there. But it can be helpful for more of a gut check. So what I've done is I've added this tool calling eval. When you're evaluating an agent, obviously you can look at the overall inputs and outputs, but then from there you start to kind of break down individual steps that you want to dive into in more detail. A router is a really easy place to start to just make sure if you have a router, you're routing to the right kinds of steps and functions and things as you go through. So I've added this tool calling eval. Again, we'll share the notebook, but just to kind of glimpse the code there quickly, what I've done to kind of make that happen is I've pulled out all of our LLM routing spans from Phoenix, and then I have run this LLM classify call that we have in our library to run an LLM as a judge prompt that we have, again, within Phoenix across those. So that gives us a bunch of scores and labels. And then you can see our rolled up amount here of our tool calling evals. We're mostly correct, but there's a few that are off. And so from there, I might go into a little bit more detail and want to see what those look like. So I'm going to load up individual spans, and I'm going to filter it down to the cases where our router messed up. So let's do... My one-handed typing isn't bad. All right. And we'll look at just the incorrect labels. And so in this case, you see the 3 cases where we messed up. If I pull one of those open, I can go into this feedback section here, and I can take a look at what went wrong. And so one nice thing about LLM as a judge is it can also generate explanations of why it marks something as incorrect or why it marks something as correct. And so here we have, in this case, we made a tool call to look up sales data, which was good. But then we didn't make a tool call to our visualization generator. So it messed up in that one case there. And so from here, again, kind of on this one-to-one section here, I could actually take this and I can go use this playground tool that we have to modify what we just ran and test it out in different ways. So if I go into the playground, that's going to take everything from that particular LLM call that happened in the past, and it's going to populate this whole section here. And so you can see all the different responses, the tool response, and then you can also see the individual tools that are passed to our agent as well. And so I could just run this again, see what I get. I could tweak any part of that. I could tweak the tool description right in the UI here. I could also compare this against other models or other kind of approaches if I wanted to do something more side by side. And one thing that I think is actually really fun and cool is I can also go in here, say I wanted to switch this to Anthropic, and we'll do a Sonnet model here. We'll actually modify the structure of the messages and the tools and everything like that to match what that platform expects. So you can actually see we've changed the tool description and things like that to match with Anthropic. So it makes it really easy to kind of test out different, almost like what-if analysis. What if I had changed this? What if I changed this? Would it give me a different output? So this is helpful from a kind of one-to-one gut checking perspective, but again, it's like one-to-one. We're looking at one example. It's like very specific. So how do we take this and make it a little bit more of a scalable kind of evaluation? And to do that, we're going to use a couple tools that we have in the platform called data sets and experiments. We're going to go more towards the evaluation-driven development kind of side of things, which is where if I go into our data set section here, I have kind of pre-populated a few examples or a few sets of example inputs and outputs that we could look at. So for example, if we wanted to stick evaluating our router, our tool calling ground truth is a set of examples that I added in here, different user queries with expected outputs. So which function should be called by that particular input. And so I could take this and experiment from here just to have a little variety here. I'm actually going to switch it over and we'll look at another one, which is I created another example here of these sales database lookup questions. If you remember, there's a step in our agent which generates SQL to look up data from this database that we have. So in this case, this is a bunch of inputs that we have, and then the expected output from that SQL step. And so what I can do is first off, I can create this data set. This can even just be like a CSV that I upload. It doesn't have to be anything crazy. You can do it in code. You can just upload a CSV either way. And then I can take this and I can go back to our playground and run different iterations, experiments, whatever I might want to do from here. So in this case, I have our prompt, so I'm just going to steal the prompt from a different page, and I'll dump that in here. And so now I basically added in our prompt, and it's looking for this question variable here, which has been pulled from my input, my set of test cases. And then now I could make changes to this. I could modify it however I wanted to. I could add more compares for side-by-side kind of things as well too. And then set up that however I wanted, run it, and it will go through and we'll run each of those examples through our model to get our outputs here. And then you can see we've got some SQL outputs. And this whole kind of run will get stored as an experiment within the platform. So we'll store this data, and we get all our outputs from that particular iteration of our application. And then from there, we can actually evaluate how those results perform compared to our ground truth or using some other kind of evaluator. So if I go back here, I'm going to grab it. I'm going to do it in code here. And everything I've shown you in the dashboard can be done in code just using our libraries. Some people prefer that kind of approach or using the dashboard. And then what I've done in my messy notebook over here is I've set up a method here that can evaluate our SQL results. So this basically takes an output of our application and the expected output, and it will actually get the resulting data from our SQL database based on that SQL that we generated. It'll compare it to our expected output. I have it just comparing the numbers to kind of avoid cases where columns got named different things in the output of SQL and stuff like that. But I can set up my evaluation function however I wanted to. And then I can take that and I can run the experiment that we just did using that ID. I can have that evaluator run across that. And of course I got something in there, but I think it still worked. So I can run that evaluator across all the examples in our data set there. And if I refresh the page here, we should get a new row in this case where we've evaluated the success of that run of our experiment. So from here I could do more experiments. I could test out different variations within the application, continue to use these same evaluators to get more comparable results over time here. I'm running a little short on time, so I won't show you guys the last one of those, which is evaluating another tool within the agent. But hopefully this gives you a picture of how you can kind of build up a few different iterations of your tests and your evaluators and then use those to evaluate targeted parts of your agent or the whole run through of your agent as you're setting up this different sort of testing battery, if you will. And so, just to finish it off, from here you could go through and you could add more evaluations, you could add more test cases that you're testing against, continue to kind of build up this set of integration tests almost that you're running on your application as you're building it. And then once you have that in a good place, you can attach these to CI/CD flows where, say you wanted to actually have these experiments run whenever you make a change to a code base. We have a whole guide on how you can set up those triggers to use this as almost like your integration testing when you want to push new code. And one kind of pro tip that I would throw in there as well too is that your application or your agent can degrade in performance even if you're not making changes to it because of changes to underlying models that you're using. You might just start getting different inputs from users or different kinds of inputs. So you can attach your experiments to CI/CD flows, but I also always recommend just running them on a regular cadence as well too to check for those other kinds of degradations in performance that might occur. And then finally, as you've deployed your application, you can kind of complete this cycle and take the production learnings that you have and fold them back into your application and your testing battery as you go. Cool, and that is about all I have for you guys. I showed you some pieces of Phoenix. There's a bunch that I didn't touch on. Everything from annotations, some fine-tuning features, some prompt management features, a bunch of other things in there. Again, fully open source, free to use, so please check it out if you haven't already. And that's about it from me. I think I have time for about 1 or 2 questions if anybody has anything they're wondering about. So how did I create the router to evaluate the agents? So the router is a piece of the agent that I evaluated. So I created that just using an OpenAI kind of call with some functions that have been passed to it. So I can show you the code for that if you're curious. We didn't use the router to do any of the evaluation afterwards, but we evaluated the router, in this case using an LLM as a judge approach, where we basically passed in the whole function definition that the OpenAI model got, as well as the user prompt, and then had another model kind of critique whether the choice was made correctly given that user prompt, like did they choose the right tool, essentially. I think with evaluating routers and function calling, it's almost better to use like a set of test cases that you can compare against. I just kind of like showing the LLM as a judge approach because it's really quick and easy to do. You don't have to go create a set of like a golden data set. So if you're gut checking in the beginning, it's kind of a fast way to get going. I think as you went forward, you'd want to have that kind of golden data set to test against though. Cool. Yeah.
Evaluation-driven development, when you run that iteratively on each pass, is it providing any feedback to me as guidance or recommendations where, let's say, the tools description needs to be improved so that I can be able to iterate faster?
It's a great question. So just to repeat for everyone who didn't hear, when you're running evaluation-driven development, you're running all these tests, are you getting any feedback or does it provide you any feedback to actually know where to make changes and know where to modify things? Short answer is in Phoenix, not really. You kind of have to have that sort of knowledge of what do I do with this information and trying different things from there. Phoenix is one of the products that we make at Arize. We also have an enterprise platform, and we actually have built an agent into that platform that will kind of ride along with you, and it can do exactly the kind of thing where you're saying. It can look at that and say, hey, you should change this function definition, or you should change this, this prompt, or whatever it might be. So that's one of the sort of, you got to pay for that feature, unfortunately. Cool. All right. Thank you guys very much. Really appreciate it. Next up, we have Lori from LlamaIndex. Sorry guys, I have forgotten to do this at every event we've had. I'm gonna do a really quick selfie before I forget and go off stage. That's cool. All right, everybody. Turn around. Come on. All right, smile. 1, 2, 3. Thank you. Sorry.
Dude stole my trick. I was always gonna do a speaker selfie. It's how I get you on my side. Anyway. I'm going to do it anyway because I always do one, so. Pretend you've just heard a really great talk. All right. Hello, everybody. I'm Laurie. I am head of developer relations at LlamaIndex. In a former life, I co-founded NPM Inc., so you may remember me from when I used to talk incessantly about JavaScript. Now I talk incessantly about AI. The common thread is that I talk incessantly. What I'm going to be talking about today is LlamaIndex. I'm going to talk to you about what it is, what it can do for you, including retrieval augmented generation, world-class document parsing, and structured data extraction with autonomous agents, which is a whole bunch of stuff that I'm going to explain. So first, what is LlamaIndex? It is a bunch of things. Start with the most obvious. We are a pair of open source frameworks in Python and TypeScript that help you build generative AI applications. But that is not all that we do. We also have a very popular service called LlamaParse. What LlamaParse does is it takes complex document formats, so think PDFs, Word files, PowerPoint, stuff like that, and it converts them into a format that LLMs find easy to understand. This turns out to be critical to generative AI applications. Having complex data turned into a format that it finds easy to understand will give you demonstrably better outcomes with the applications that you build. We also have Llama Cloud, which is our enterprise service. If what you want to do is stuff your documents into one end and run retrieval augmented generation on the other end without having to think about any of the stuff in between, then that is what this service is for. You can think of it as LlamaIndex building a LlamaIndex application for you. It's available as a SaaS at cloud.llamaindex.ai, or you can get it deployed on your own private cloud. And that is the end of the sales pitch. We also have a thing called Llama Hub. This is a huge repository of open source software that will further accelerate your ability to build generative AI applications. We have stuff like data loaders to connect you to your databases. We have adapters for embedding models, vector stores, LLMs. We have pre-built agent tools, so you don't have to build your own. And we have pre-built whole query strategies that you can just import into your application wholesale. Why should you use LlamaIndex? Because we will help you go faster. That is the whole point of programming frameworks in general. We will help you skip the boilerplate. We will help you avoid early pitfalls in coding. We will give you the best practices for free, and we will help you go from prototype to production. So let's talk about what this framework can actually do for you. One of the biggest things that we do is RAG, which stands for Retrieval Augmented Generation. Hands up if you feel like you know what RAG is already. That's about half of you. Okay, so I'm going to do a very quick recap. Oh, and a question I meant to ask at the beginning. Hands up if this is your first Tech Talk of the year. Hands up if this is your second Tech Talk of the year. Third or more. Y'all are very enthusiastic. I don't understand. It's the 15th, people. What were you doing? Anyway, so let's quickly explain what RAG means. Retrieval augmented generation is a response to a fundamental limitation of LLMs, which is that they understand all of their training data, but their training data doesn't include your data. You have to give them your data, and they have limited context windows. They can't take all of the data that you have in the world at the same time. You have to be selective. That is where the retrieval part comes in. You select very specific parts of your data that are relevant to the query, and you give it to them to be able to answer questions about your data. The tricky part is figuring out what parts of your data are relevant to your question. Using technology closely related to LLMs called embedding models, you convert your data into arrays of numbers called vectors. And the total set of available vectors is called vector space. So the conversion of your data into these vectors is known as embedding it into vector space. And so the resulting numbers are called embeddings, which is like 3 degrees of indirection away from the thing that you did. Computer scientists are bad at naming things. But the magical thing is, if you then take your query and you embed your query as well, your query ends up mathematically nearby in vector space to the data that answers that query. This is just a magical feature of how embedding models work. So then you can do very simple maths that finds the data, the vectors that have been embedded close to your query vector, and those turn out to be the data that is most relevant to your question, and that is the core of RAG. So that is the theory. Let's talk about how you build a RAG pipeline in practice.
You have to ingest your data, you have to parse it, you split it into chunks, you embed those chunks, you store them in a vector store of some kind, and then you use your query to retrieve, like I said, the most relevant chunks of your data to answer your query. You then send your query plus the relevant data to the LLM and you say, figure out what to do, and the LLM hopefully gives you a relevant response. Let's talk about how you do that in LlamaIndex. This is a full RAG application in LlamaIndex in 5 lines of code. You can see us loading our data on the first line there into documents. You see us creating a vector store index, which is also doing the embedding for you. We then create a query engine, and we run a query and get the response. This is the entire thing, but the point of this talk, indeed the point of LlamaIndex in general, is that there is more to this problem of retrieval augmented generation than just 5 lines of code. Naive RAG is limited. It tends to work on smaller sets of documents on relatively simple questions, and there are a number of ways that naive RAG can fail. There's 3 ways that I wanted to mention. The first is summarization. If you ask your RAG pipeline for a summary of your document, what it's going to do is it's going to look for a summary of your document that is already inside of your document, right? That's what it does. It does retrieval within your document. So unless your document already contains a summary of itself, which documents don't usually do, it's just going to not know how to do that. It's also tricky with comparisons. If you ask it to compare 2 things in your document, it is going to try and retrieve both of those chunks relevant to both of those things that you're comparing at the same time, and then compare them in a single shot, and it's not necessarily going to know which chunks are about which thing it's comparing, so it can get confused when doing comparisons. And finally, just in general, it's bad at multi-part questions. If you ask it to do a summary and then do some extra stuff with that summary and then take a third thing, that's not what RAG is for. RAG is for answering a single question very quickly. Which isn't to say that naive RAG is useless. Naive RAG is incredibly useful. It's kind of magical. But it's not all you need to get knowledge assistance done. Lots of tasks require the semantic search, which is what RAG is. But to fully build knowledge-aware agents, we have to go beyond the limits of RAG to fully utilize the power of LLMs. And there's 2 ways to do that. The first is you can improve your data quality. Improving your data quality is why we built LlamaParse. That's what it does, is it takes complicated data and makes it better as far as the LLM is concerned. But the thing that I'm going to be focusing on mostly tonight is improving your query sophistication. There's a whole lot that you can do that is beyond just asking a simple question about your data and getting a response. And the way we're going to be doing that is we're going to be using agentic strategies. And that brings us to the obvious question, which is, what is an agent if I'm using an agentic strategy? Agents is a term overused to the point of meaninglessness in this industry. People are just saying anything with an if statement is an agent these days. What I mean when I say an agent is a semi-autonomous piece of software where you are letting the LLM make decisions based on data. That is a radical departure in the way programming is done. Programming is usually you give it a specific set of information, you give it a specific format in which you want it to change things, and you give it a set of instructions. In this, you just give the LLM a goal and a set of tools, and you get the LLM to kind of figure it out, which works to everyone's surprise on a regular basis. So let's talk about some agentic strategies and how we can build them up into a full agent. A naive RAG pipeline has a bunch of limitations. It's single shot. It doesn't understand the query. There's no tool use, so it can't get additional information about the environment. It has no reflection or error correction. So if it gets a bad answer, it doesn't know that it gave you a bad answer. It just gives you a bad answer. And it has no memory. So every additional question becomes a totally new interaction with the LLM. We can do a lot better on all of those fronts by using agentic RAG. We can make the process multi-turn. We can add a query or task planning layer so that it thinks about what this question is before it decides how to do that, how to answer that question. We can give it tools that allow it to interface with the external environment, get additional information, stuff like that. We can give it reflection so that it can look at the answer that it has generated and decide whether or not this answer is actually a good answer, and if not, it can take further action and improve its own answer. And you can also give it memory. Basically, it can remember what it has answered previously and be able to do better than that. These strategies that I'm talking about exist on a spectrum from simple to complex and from cheap to expensive. So you don't necessarily want to build a full agent immediately using all of the strategies in your toolbox, because it might be expensive to build or it might be really slow to run. Let's look at these strategies one by one. One of them is routing. This is the simplest form of agentic reasoning. You give your LLM a set of tools, and the router uses the LLM to select which of these tools is going to best answer the question. This can solve, for instance, the summarization problem. So instead of just giving your agent a RAG pipeline, you give your agent a RAG pipeline and also a summary tool. And if it gets a question that looks like a summary, it will use the tool that gives you the summary to solve that problem instead. The next tool that we can add to build up to an agent is memory. This is theoretically simple. You just store every interaction that you've had with the LLM already, and you feed it back to the LLM saying, this is what you've previously discussed. It can get complicated as your conversations get very long. You have to be selective. You have to sort of run RAG on your own memory to figure out which bits of the things that you remember are relevant to the conversation that you're having, stuff like that. We can also add one-shot query planning. What this does is it takes a complicated question and it breaks it up into simpler questions that RAG finds easier to understand. You then take those simple answers with their additional context, and you generate a single answer from all of the answers that you've received. The way that we make all of this happen, I've just been talking about it as if it's a foregone conclusion, is tools. One of the really surprising things that LLMs can do is use tools. They are fancy autocomplete, so how they suddenly got this ability to fill in an API and use the API is kind of surprising to everyone involved, but they work. They can use tools. And the result is that your LLM can get the state of the world, not just documents. It can even modify the state by taking actions using the tools that you've given it. Tool use doesn't just have to pass a query to a different piece of software. Tool use can modify your query to match the task that it is being assigned. So one of the tools you can give your agent is a SQL database, and your tool use will modify your query into a SQL query to use your SQL database. Or if your tool is a calendar API, it can generate valid calls to that calendar API and create events on your calendar as a result of the decisions it's making. So those are the basic agentic strategies: routing, memory, planning, and tool use. But they are just the minimum necessary to create an agent. We need to go further. Like I said, we need to make it multi-turn. We need to give it reasoning and planning. Let's give it reflection, and let's talk about how we get those things done in the 4 minutes that I have left. There's 3 types of agentic reasoning loops that I want to talk about very briefly. They are sequential, DAG-based, and tree-based. These also live on a spectrum from the simplest and cheapest to the most complex and expensive. The first is sequential. The pattern most common here is called React, not React the web framework, but reasoning plus action. It's also sometimes known as chain of thought. In React, your agent generates a thought, it makes an observation, and then it decides what action to take, and it just does that over and over. It's just like, what am I doing? What should I do? I've done that thing. Have I completed my goal? No? Okay, I will take another observation and go again. This is surprisingly effective, but it can fail with complex tasks. So the next step up is DAG-based reasoning. A DAG is a directed acyclic graph. You can think of it as something like a flow chart, bunch of boxes and arrows connected. In DAG-based reasoning, you get the LLM to plan out in advance how it's going to go from nothing to the answer. in a series of steps that are interrelated, and then perform those actions one after the other. One of the interesting things that it can do there is it can course correct. So it can say, okay, after step 3, I was expecting to have the text of Moby Dick. Instead, I have an error message. I have done something wrong. Let me come up with a new plan of what things to do. That is the reflection that I was talking about. The ability to self-reflect, the ability to course correct is a huge advantage of using agents over a naive RAG pipeline and just declarative programming in general. The self-reflection gives you the LLM gives the LLM the ability to decide whether it has completed the task and course correct if it hasn't. But still, DAG-based planning works best if you've got a task that is sufficiently constrained that an LLM can figure out from 0 to the end goal in a single shot. And tasks are often more complicated than that. When you want to go more complicated than that, you can use tree-based reasoning. There are a bunch of tree-based reasoning algorithms like tree of thought, reasoning via planning, and language agent tree search. Language agent tree search is built into LlamaIndex, so it's the one that I talk about most often. What they have in common is that they don't know in advance how they're going to solve the problem. What they do, as these diagrams suggest, is they come up with a tree of potential universes that are created as a result of their actions. So they say, what if I took this action? Okay, what would be the state of the universe after that action? In that universe, what if I took these 2 different actions? In each of those universes, what if I took these 2 additional actions? And then it looks at the leaves of the tree and says, which of these is closest to the goal state that I was trying to get? It then picks that branch, follows those actions down that branch, and then starts again generating a new tree. As you can imagine, that takes a bunch of LLM calls and a bunch of observations. So it's a very expensive, but a very flexible and powerful pattern. That's what I said there. So at this point, we're pretty deep into LlamaIndex, and the last thing I want to cover in the 0 time I have left is workflows. These are a fundamental building block of LlamaIndex. They are how you put an agent together. I'm just going to save some time. A basic workflow looks like this. You create a class that has steps, and the steps are connected by events. So you declare which step receives which event and what types of events it generates. And using that, you can produce a tree that looks kind of like this of how your data is going to flow around your system. So in this one, you're seeing the reflection and error correction that I was talking about. You see it starts at the start event, it tries to answer a question. If it generates a failure, it goes to the improve query, which generates a query event, which goes back to answer query. This is a very flexible and powerful system that allows for looping, branching, reflection, map reduce, that kind of stuff, a whole bunch of stuff that it's very difficult to do with more rigid graph-based approaches. I could go on about workflows for a long time, but I don't have time, so I'm just going to leave it there, I think. What happens next is up to you. We are excited to see all of the stuff that you can build with what we've put together in this framework. This link is to our Discord. We love feedback from the community on how you find this stuff easy or hard to use, whether you think our documentation sucks or is great. Please get in touch with us. All of the slides and examples that you just saw are available at this link. And I hope this has been a useful introduction to LlamaIndex and the wider world of agentic systems. Thank you all for your time and attention. Do I have time for questions?
Go for one.
Okay, one question. Who's got one really good question? Over there. When will Llama Cloud be generally available? Are you a plant by our marketing department? That's amazing. If I wasn't our marketing department, I would assume that you were. GA is going to be very soon. We have been sitting on this for a long time. It is very, very close to ready. We are basically kind of waiting for a good time rather than adding any features to it. But thank you for that question. One more? Yes.
What's your data privacy policy on LlamaParse?
That's an excellent question as well. A data privacy policy on LlamaParse is, by default, we will cache things for 24 hours in a cache that is private to you. That is just for performance reasons. If you want no cache at all, that is just a flag to the system. The data will just get parsed, be in flight, and come back to you. If that's still not good enough for you, because obviously that's still a SaaS, there is an on-premise version of LlamaParse where all of the data and processing stays inside of your network. And thank you both for those excellent commercial questions. Great marketing. Thank you very much.
Awesome. Thank you, Lori. Just as a quick reminder, I know a bunch more people had questions, so if you have questions that we didn't have time to answer, join our Arize community Slack. You can drop them in the channel that we have in there. All of our presenters are in there and can answer some questions as well. For our last talk tonight, we have Ben from Groq, from Groq. Excuse me. There we go.
Hey everyone, how you doing? I'm going to get set up quickly here. Let's see the magic happen. Ah, perfect. All right, today I'm going to be talking to you about agents, big surprise. Specifically, I'm going to talk about agents, building agent systems with Fast Inference. But before I do that, who am I? I'm Benjamin Klieger. I'm a software engineer at Groq. I'm also a researcher at the Stanford Autonomous Agents Lab. And before we begin too, I want to show you two things. Let's zoom in. First thing is I want to tell you about Groq and what Groq is. This will be my only plug. Groq is a company that provides fast AI inference. And we do this through our custom silicon called the LPU, Language Processing Unit, that allows us to run AI models really fast. So how fast, you might ask? I will give you an example. Let's open a new ChatGPT tab. Let's see, let's write a tic-tac-toe game in Python. It's working on it. It's going. The canvas is pretty cool, I have to say. It's getting there. A little bit longer. And, okay, awesome. What does that look like on Groq? Let me show you. Done. There it is. Pretty cool, right? I can do that again. It's kind of fun. Done. So that's really cool. And I think a lot of speakers have talked today about agent systems and agents. One of the themes is that agents, you can make it really complex and you can scale agents, but that takes a lot of tokens. And so what I'm going to talk about today is giving a brief overview of what are agents, and then I'm going to talk about how can you actually use this amazing inference speed to improve your agents. The first thing that's really important, I think as you heard earlier, is definitions. Maybe not really important. I think that the difference between agents and agent workflows is less important in terms of building. I think you should be building based on features and need from your application. But it's a pretty common discussion now. Simon Willison has a couple great tweets, which is basically, if someone says you built an agent, do you know what they mean by that? Probably not. But here's the thing, this actually has been an issue that we've been dealing with for at least 30 years. Because defining what an agent means has been complicated even before a lot of generative AI. If you think about computers, and we had pedagogical agents. And so I line up with Anthropic's definition, because I think the most important part of agents is agency. I think you heard that earlier. Basically, the idea of an agent is that it's something that has sort of agency in what it's choosing to do for the workflow. So you see, this is from the Building Effective Agents article from Anthropic, which I really like. So I highly suggest checking that out. They define workflows as systems where LLMs and tools are orchestrated through predefined code paths. Basically, like if you can tell and predict exactly what's going to happen with the agent when you send your query, it's probably a workflow. And agents, on the other hand, have that autonomy to dynamically direct their own process. And we'll get into this a little more. One question is, when should you use agents? I won't go over this too much because I think the previous speakers did a great job. This is from our Groq Thoughts paper. You can find these on our website under the papers section. There's a few examples. Reflection, we talked about that previously in the previous talk. So thinking about checking your own work and improving. Tool use, really important. Let's say you want to search the web, use a calculator. Planning, let's say you want to plan out what you need to do to complete a task, and then the AI does each step. And then you also have multi-agent collaboration, which is pretty cool. So you can have multiple agents working together, either because you want greater interpretability into what they're doing, and so you can see them modularized, or you may want the opportunity to actually work within that team. I have a few open source examples here. So everything you see today will be open source. I want to show you one of these. I'll show you an example of an agent. I think this will reflect some of the things that we've seen from the previous speakers as well. I would show you it like this, but the problem is it goes so fast I have to pause it to show you what's happening. So I'm asking here, if Microsoft donated all of their assets to cover the United States federal debt, how much would the debt decline? Provide a percentage answer. It's kind of an interesting question. Maybe brainstorm and maybe guess what that will be. You'll see. The way that this works is the agent decides when it wants to take another reasoning step, when it wants to use a tool, and what it wants to do. And you'll see that agency reflected here. So it starts thinking, how would I decompose the problem? It goes and it uses Wolfram Alpha to actually get the United States federal debt. It gets that number. Uses the same tool for Microsoft's total assets. Again, going so fast. But what it finds is that the assets are not available, so then it chooses actually to use web search and to find it from that. Something I couldn't have predicted knowing it would do. Another reason this is more of an agent than a workflow. And then it chooses then to use code execution, which will come up in a second, to calculate that the answer is that the United States federal debt would decline approximately 1%. So a little bit. So pretty cool. I have lots of demos here, but for the sake of time, I won't get into too many. Happy to show you them too afterwards, though. And you can find these all on my GitHub. I'll have those linked at the end. But I want to show you and talk about building agents. So the next step is like, OK, this is really cool. How do you build this? Lots of great ideas and code examples from the past two speakers. One thing you can think about is, should you use an agent framework? I'm going to give you like a general overview of like what the industry thinks and what's there. A lot of people like agent frameworks because it helps you get started fast and you can use good practices that are automatically baked in. And I think those are right. But there's also two major criticisms of agent frameworks I think are helpful to keep in mind if you do use them. This is also from Anthropic because they've done a great job with this article. But the two things that I've run into is, one, frameworks can abstract sometimes things that you may want to abstract. One of the cool things about LLMs and AI in general, generative AI, is they're very new, they're very novel, and they're non-deterministic. So you get interesting behaviors and changing small things, like, for instance, how do you parse tools? Do you use code or do you use JSON? That's a real example that's happening and shifting in the industry right now. And because of that, you want to have the ability to experiment with things on a lower level. So sometimes it makes sense to do that. And you want to keep that in mind. If a framework's abstracting that, you may want the ability to go lower level. And the second thing is, sometimes you want to make sure that frameworks aren't encouraging you to build overly complex solutions. I mean, 90% of the time, I would say you should start with a workflow and not an agent. And the difference really is a matter of a small feature or two that adds that autonomy. I think you should really drive your solutions based off of what you need and what you need to build in terms of the functionality. And so I think that's important. So sometimes it may be tempting to like build out a really complex agent or bring up a more complex topic. But sometimes you need to take a second and think, what do we actually need? But I think if you keep both those things in mind, you can use different frameworks and you can use them well. I have three frameworks I really like. Of course, LlamaIndex, put that there. I also like Small Agents, came out recently from Hugging Face, which I think is like very minimal if you're looking for something that is a really nice scaffold. And Pydantic AI has some great tooling as well. So those are the three I would recommend. And then, a time check. So another thing, now that we have this fast inference, we know here are some ways we can build agents. There's open source examples. How do we actually build it? And more so, what do we do with all this fast inference? So that tic-tac-toe game that went at 3,000 tokens per second, amazing. What does that mean? I can't read that fast. So actually, I want to show you one other thing in the meantime. I want to show you another demo to show you the speed again. And then I'll show you a way that we can harness that in an agentic workflow. So this is called Infinite Bookshelf. It's an application where you can write full books. I won't tell you how long it'll take. You'll see. Maybe be surprised. About any topic, any nonfiction topic. So does anyone have a nonfiction topic, something you want to learn about today? What was that? Aliens. Okay. What about aliens? What other topics too? Let's have it be more specific. Okay. Wait, I like that one. Hold on. Talking with a mic or typing with a microphone is harder than it looks. What are some additional instructions? Like when I ask it for learning about large language models, I have it give me code examples. What else could we add here? It could be anything. It could be like talking haikus.
Writing rhymes.
Yeah, okay. That's right. Let me add the haikus in. This is a little complex, but let's see how it goes. Okay, first off, it's already generating. It's hard for me to keep up. This is all being generated right now. It's coming. Oh, there's the haikus. Oh, this is the legacy. Hold on, let's scroll up all the way to the top. Okay, so we got a story here. The rise and fall. Okay, so we got a table of contents here. We can see after here now the founding fathers of the Roman Empire. There's the haiku. We have the rise to power, another haiku. So you get the idea. It's really cool. This is really cool if you want to learn about topics. That said, I don't know about you. I can't read this fast, I'll admit. So what do you do with that? Well, one thing you can do with that inference speed is you can create really cool workflows. This is, again, so that app was open source, also another open source app. It's called Stockbot, powered by Groq. And so give me any stock. Okay, I heard Apple, I heard NVIDIA. Hold on, let's do both. So the idea of this is that you can ask questions, and it's going to use workflow really fast to pull in live interactive data and visualizations. Show me the price of Apple. Let's see. There we go. So this is the live price of Apple. Actually interact with that. Let's go to NVIDIA. There we go. It's a good day in the market. I tried to do this once on a bad day in the market, and I realized I just had to wait till the next day. It was too sad of a demo. Yeah, we got lucky. Today's actually a very good day. There's a heat map, interactive. So anyways, this is the idea. Things can open here. Really cool. Let's talk about how do you do this and what this means. So the idea of fast inference and the reason why it's important is because you have a larger token budget to do all this on the back end for those agent systems. This is another quote. Agent systems often trade latency and cost for better task performance. We heard that before. But when you 10x, 20x the amount of speed you have a lot more space and budget there to have maybe a workflow that is 10 times bigger, but still is only 1 or 2 seconds of latency for your users. There's 3 ways I think I want to give you ideas for how to scale agents. I'll talk about them briefly. Happy to talk more afterwards. The first thing is just scaling the number of agents. Surprisingly, this works really well. I mean, it kind of makes sense, but it's like even the same agents, and exact same, and just having multiple agents, and then using them to vote on the answer improves accuracy over time. So you see ensemble is like number of agents. Similar to majority vote, so basically like you have the majority vote is you have the AI, the same AI, just generate a bunch of answers, and then you see what's the most common answer. So you can scale number of agents. You can use that in creative ways. It doesn't have to be the exact same agent. But you can also scale the depth of workflow. This is from Storm. It's a really cool application coming out from Stanford. And the idea is it's basically a way that agents go and actually research for you to create a research report on any topic. And so in this case, you can look at this, and this is a case where you're really scaling the depth of workflow. So instead of just having, let's say, one agent look at the first 2 research articles that come up from a search on archive. Imagine if now you have the latency and the space because of that fast inference to search through the top 20. Or maybe you search through the top 5, then you have 2 agents debate over which is most important, which actually improves accuracy. Look at LLM debate paper. And then you have it create a summary. And you do all of that in the same time. It would usually take you to just have one agent look at 2 reports. And then finally, we've seen with test time compute, you can just scale token usage on an individual level for how the models are working. You can use things like O1 and other reasoners that are coming out, and you can even scale it with traditional prompting techniques, and I think there'll be even more opportunities in the future. So yeah, thank you for your time. I'm happy to answer any questions, and happy to show you those demos too. I'll be right around here afterwards. Thank you. Yes.
Okay, I have a really pertinent question. This gentleman over there in jest asked you to have your engine tell us about aliens. Yes. Okay. I spent 16 years with NASA, and I can tell you that if you did ask your engine to tell you all about aliens, it's nothing but garbage. Okay, I went to look, okay, on the internet, it's garbage. Okay, so my simple question is this. Does your workflow have some way of scoring or ranking the data quality such that you can say, okay, I only want this level of certainty, such that you're not pulling in garbage that's tainted?
I think that's actually a great example. I'm really glad you brought it up because that's the point of agents. So if you just ask an AI about a topic it's maybe unfamiliar about without an agentic workflow or an agent, it will give you something kind of off of memorization, if that makes sense. But what would be really cool is if you have, so cool you have the experience with NASA, I bet they have articles about different things. And so you could have an agent that actually pulls answers specifically from verified sources and have those citations. So instead of it being something that's done by memorization, you can actually be pulling in human verified data and pulling in that expertise and having that be part of the answer, which will get you to a higher quality answer. And of course, the more tokens you have available within that latency window of, let's say, 1 or 2 seconds, the more sources you can parse, the more debate you can have. You can do that scoring as well. So lots of great ideas. I hope that helps. Anyone else? Yeah, in the back.
What is being traded off for the fast inference speed?
Nothing being traded off. It's just running on LPUs instead of GPUs. You also get like cheaper pricing too. So I guess if you want to, like, instead of using all those tokens, you could also trade off and you can have lower costs. So you can still choose. But yeah, super fast. Anyone else? In the front?
Yeah, when you mention multi-agents to check between them the responses, you mean that each agent should be like the same, like a duplication of each one of them, or they should be?
Is this for the number of agents? Yeah, I'd refer to more agents is all you need. I believe for this paper they were the same, and then you can do voting, which is similar to the idea of majority vote. But you could also have them doing something like debate. So there's a really cool paper that looks at having, it wasn't agents at that time, but two AI work together, and they would both provide a response, and they'd be different. And you have the same AI use both of those and consider it to be a debate and see which one's right, and then go through a few rounds until it settles upon an answer. And that improves the factuality and the accuracy of these agents or the AI answers significantly. Does that answer your question?
Yes, I have way more questions, but
You can catch me after. Happy to answer. All right, thank you, everyone.
Thanks, everybody. All right, I'll be 30 seconds and I'll release everybody here. Just 2 quick reminders. First, if you want to get a special Arize hoodie, come talk to Nick afterwards. Let him interview you very briefly right over there. And thank you to everybody who's done some social posts already. Reminder, we have a giveaway for a Theragun. All you got to do is do a social post, tag us, tag LlamaIndex, tag Groq. And thank you, everybody. We're here for another hour, I think, another hour. So hang out, come talk to the speakers, and thank you very much.